Hello, welcome to my stream. I'm Mike, and I'm going to be talking about NPN transistor circuit switch. NPN transistor switch circuit. Sorry, but I was doing something earlier, so I got this kind of set up wrong. Okay, now my last video I went over this basically, the transistor, but I made the first video showing how it worked as a switch, and now I'm going to be showing, excuse me, I showed the first circuit. First video I showed you how the NPN transistor worked as an amplifier. And you see, I'll show you real quick. Sorry, that's my wife and my daughter, 3-year-old. So she keeps us busy. Okay, this circuit. Yes, this is this circuit with the same thing, the same component, but used with different components. It's used as an amplifier. Get you this nice signal, maximum, maxed out. Where you can see there's no clipping. It's just perfectly round at the bottom and at the top. Where as a switch, we don't care about that. You'll see real quick that we could care less about that. Get this set up so I can explain it. When you can see test points on the oscilloscope. Top part is the oscilloscope, and the color marks. These are lines, are leads. I call them leads. They represent different areas that we have marked on the circuit. So that being said, this circuit here is set up for as an electronic switch. We have a signal input going into the base of the transistor, and that is at 60 hertz, and the signal is 0.7 volts, pretty much 0.7 volts. No, I got 707 millivolts. That's that has to do with I can get it close as possible, going down and then going back up. Get that spike. Get a long spike without it being too long, looking messy, just so you can see it's clear, on and off, turning on and off. And the LED shows you when the transistor is on. When the transistor is on, it lights up. And we have a 5-volt source that's powering it. And so when the transistor is off, with the green LED, as you can see, will be high, basically 5 volts. Now we got a little bit of voltage drop, and that's because of even when it's off, we have a little bit of a voltage drop. So it's supposed to be basically 5 volts, but we added an LED. So now whenever you add two components in series, it wants to act like a voltage divider. So that's why you see a little bit of a voltage drop at the collector of the transistor. So, all right. When the signal going in is under 0.7 volts, the transistor is off. As it goes up, it turns on. So with no setup, with it not being set up as an amplifier, it's in the setup for as a saturation. The emitter is grounded. It's set up for either off or saturation mode. So the emitter is grounded, and we have a resistor on the collector that tells you it's only being used as a switch. So once it reaches 0.7 volts, it turns on. Once it drops below, it turns off. There's pretty much no in between. And that's it. That's how it works. So when it's off, you know that all the voltage is sitting right there on the collector, waiting to go through the resistor. Once and it's going to remain that way until it's turned on. Once it's turned on, it's going to drain all the way, puts it in all the way in saturation mode, which means it's on as it's going to get. Can't get no order than that without burning up. So yeah, that's pretty much it. That's how it works, and that's all you're doing. If you speed it up, you see the signals. Slow it down, you can observe what's going on better. And we have a capacitor here. So the reason I have this capacitor here is to help stabilize the output, because transistors have and a lot of the components, even the human body has capacitors. Sometimes you like an old-fashioned radio, you touch the antenna, sometimes you get a better frequency, sometimes you mess it up. Yeah, that's capacitance. This resistor, the transistor has basically a small capacitor effect. But if you take the external capacitor out of the circuit, which is what I just did, and you'll be able to see that effect. Because again, once capacitors resist change in voltage by providing more voltage. Once that voltage starts, once the voltage starts being taken away, it tries to make up for it. So without that, that's kind of what's happening here. Okay, the voltage going down and it's off. So as it comes back on, transistor starts turning on, but the capacitors, see the capacitance in the transistor detects that and tries to add to it to keep it from happening, keep that change from happening, because it'll be a change and it starts coming in, and voltage will start being reduced here, and it just has a weird effect that would just make that signal messier up until a certain point. Then it gets overpowered. Then capacitance charge would drain, would just go away. It would be depleted. So then it'll start being a normal signal. But every time it hits that point, a certain point, you're going to see that messy spike. So to fix that, just add an external capacitor, which smooths it out. Basically, that's all it does. It detects that happening, and as it detects it happening, it has so much capacitor that it can just easily offset it or make up for it, compensate. So that's it. That's all that happened. Something else? Oh yeah, I already showed you in the beginning how this was used as an amplifier, and this is used as a circuit. Okay, I'm gonna wrap this up, bring this to an end, because I don't want the video going too long. But the next one, these are all the same circuits, but used in different ways. Well, actually, these two are NPN based circuits, and these two are PNP based circuits. These two can be combined to be a push-pull, working in one way, where these two can be combined as push-pull, working in another way. And yeah, that's all I'm going to do now, because every time this is like the fourth time making remaking this video. Every time I go into detail showing the other ones, I wound up messing the video up. So I'm just going to end it here. In my next video, I'm going to explain this PNP circuit, what's going on here, and then explain this, my third one, this and my fourth one, and then I'm going to show you how they work as a push-pull. Show you how the two left works as a push-pull and the two right work as a push-pull. And that's about it for now. Thanks for watching my video. But just to give you a brief highlight, this is the circuit we just looked at, and this here, push-pull.